Hey guys, we're checking our tests. So we're going to make sure we understand what the correct answers were, and hopefully for some of these I can get to why. So what we're looking at is the answers for the number one. Remember, number one, we're just looking at the 10 billions place, and we go to 10 billions. This is hundreds, thousands, millions, and billions. 10 billions place is 4, and we proceed like that. What I want you to observe is that for 6 tenths, the tenths one, I had a couple people get confused with tens versus the tenths. So the tenths place refers to this place right after the decimal, and the tens place refers to this place in the tens place, right? So I had a couple people put 5 there. But if you have any questions with that, please let me know. Your answer to this next one, write the following number in standard notation. You want 4 in the millions place, and the 0.6 is going to be after the millions place. So it's going to, or the 6 will be after the millions place in the hundred thousands place. Similarly, the 32 will be in the trillions place, the 1 will be in the hundred billions place, and then we've got a bunch of zeros. Don't laugh at my zeros. I know they look terrible. Now, when we're going in the other direction, when we're writing number in word notation for numbers in standard form, what we will do is we need to figure out what the section is that we're talking about. So this is hundreds, thousands, millions and billions. So when I get to the section, I know that that's the word that'll be here. It'll be billion. So $5.6 billion. I don't think I really need the S here. 5.6 billion. So that's what we have working for us here. So similarly, when I look at just what place is this? This is the trillions place, right? So I'm going to put 462, because that's how many trillions we have, 0.8, because that's not actually in the trillion section. It's in the billion section. All right? All right, we'll talk. So over here, when I look at these problems, I'm reminded, and I can take the answers out for now. We can talk about them together. When I look at these problems, I'm reminding of how we would count the direction of the decimal. So I know that if I would have to move this 1, 2, 3 to get back to a whole number 1, that lets me know that this is -3. In a sense, I've moved it 3 spaces to the 3 spaces to the left. Over here, 1 billion. Well, I know that 1 billion has 9 zeros after it. So that was also an indication when I'm looking at numbers that are not decimals. So if I had, let's say, 1 million, I will be 10 to the 6. If I had 1,000, how many zeros are there? 3, so it will be 10 to the 3rd. So that was a technique that I used there. Here, we see that 10 times itself 4 times would simply be 10 to the 4th power. And over here, another way of writing 1 over 10 is 0.1, because that's 1/10 and that's 1/10. And we know that that's -1 power. All right? The next thing that I'd like to talk about is actually doing these problems down here, which can be tricky. So let's think about a way that we can handle it. What we do is we say, hey, when I multiply this big number by a small number, is it going to get smaller or bigger? And hopefully you guys realize it's getting smaller. How many decimal places? I count them: 1, 2, 3, and 4 to get to the whole number 1. So that means I'm going to move this back because it's getting smaller. 1, 2, 3, and 4. So your answer is 7.6541. Again, this number is actually getting bigger, right? So I'm going to multiply, because I'm multiplying by 10,000, I'm going to move it over 1, 2, 3, 4 spaces. 1, 2, 3, and 4. So I'm left with 4,210. Over here with part C, I know that this is getting smaller. That -3 tells me I'm going in the opposite direction. I'm going in the negative direction, or the left direction. 1, 2, and 3. So I've got 0, or 0.0457. All right. Over here, I'm going to figure out, what do I need to multiply this tiny number by in order to get this bigger number, 85? So I'm going to multiply it by 10 to a positive power. So 10 to the what? 1, 2, 3, and 4. I need to move it over 4 spaces, so 10 to the 4th power will work there. What do I need when I multiply 2.9 times 10 to the 5th power? I'm moving the decimal place over 5 spaces. So it's 1, 2, 3, and 4, and 5. Sorry about that. So I get 290,000. And finally, when I multiply 0.7 times, to get 0.7, or to get 7/10, when I start off with 7,000s, I need to multiply this by a bigger number. So it's 10 to the 1st and second. So 10 to the second power, or 100. This next set of problems, we're going to basically write these numbers in standard notation, given that we're given it in scientific notation. So I'm going to move this decimal place over 9 spaces. So I'll move it over 1, 2, 3, 4, 5, 6, 7, 8, 9. Many of you got this right. This was an area that you guys showed that you really knew what you were doing. Suppose that the Earth travels at this many miles, and we need to write basically this really large number in scientific notation. So again, when we do scientific notation, it's not like number and word. Number and word, you just talk about the number in that category and you write down the word. But with scientific notation, you need to make sure that you're multiplying by 10 to a power, and the number here has to be between 1 and 10. And so the 6 we're going to put here. So 6 times 10 to what power? So 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8. Here we're doing some addition. When we add numbers, decimal numbers, we line up the decimal and we fill in. I like filling in. So 4 plus 0 is 4. 9 plus 7 is going to give me 16, carry my 1. 6 plus 3 plus 1 gives me 10. 0 down there, carry my 1. And then 9 plus 5 plus 1 is going to be 15. So the answer was 15.064. Saw a couple people confuse this. If I'm going to subtract, put my first number at the top, and I'm going to line this up. I know I just threw that 0 in there. That's because I did the problem before and I remembered, oh, we need to fill it in because we want to make sure we're dealing with the same amount of digits. This is only, at least after the decimal point, this is only when you are dealing with addition and subtraction. Multiplication is a bit different, and we'll talk about that. So now we see that we're going to do some borrowing. So I'm going to borrow here. I'll get 8 here. And now I know that I'm going to have to borrow one more time. And I get 13 and 5. So my answer is 0.58. So these are my two answers. I'm not going to use this grid because I think it's going to be harder for you to see what I'm doing. So I'm going to handle these problems down here. So it says multiply or divide. We know when we multiply problems, we do not have to line up the decimals. We just make sure that the digits are kind of lined up in a way that's comfortable for us to multiply. It just so happened that the decimals are lined up. And now we're going to multiply the way we've been working on. So I'm going to highlight this green and call this whole row the green row and say, okay, well 6 times 3 is 18, carry my 1. 6 times 2 is 12, plus 1 more is 13. Again, carry my 1. 6 times 7 is 42, plus 1 more is 43. I'm done with the green row. The next row I'm going to handle, let's call it the orange row, is going to deal specifically with the 5. And the thing is, since this is according to, forget about the decimals for a moment, this is in the tens place, so we know we have to scooch everything over. We've got to move it over. So the orange row right here will deal with all the multiplication we do with the number 5. And so now, I'm moving this over too much. Now, 5 times 3 gives me 15. 5 down there, carry my 1. I'm going to scratch that one out because this is the one I'm talking about. 5 times 2 is 10, plus 1 more is 11. 1 down there, and I'm going to carry my 1. I was just scratching out the old things that I carried, not to get confused, even though they were the same. All right, so 5 times, so I did 5 times 2, 10, carry my 1. Yes, 5 times 7 is 36. 35 plus 1 more is 36. And now I'm going to add. So I get 8, 8, 4, 0, carry my 1, and 4. So I get this number. What to do with it? I count the decimals. So you can see all together I've got 2 decimals. I'm going to use those 2 decimals here. So those are 2 decimals, and so I'm going to shift it over 2 decimals. A very common thing, I saw a lot of people give me 4,048.8, which is not correct. And I need you guys to make sure that you remember you don't have to line up the decimals here, and it doesn't just come down as it does with addition and subtraction. You have to actually count the decimals in the factors before you multiply. And finally, we're going to rock some long division. Let me give myself a little bit of space here. 36 divided into 990. 36 can go into 990. 36 cannot go into 9. So then I go next door and I say, well, can 36 go into 99? And I realize, yes, it can. And I would say 2 times. So when I multiply 36 times 2, I get 72. When I subtract, I get 27. as my remainder from this particular operation. Since 36 cannot go into 27, I know I did the very best I could with the 2 because there's not another 36 that can go into there. And the next thing I do is I start dropping digits. 36 goes into 270. After doing this and thinking about it, I'd guess 7. 7 times 6 is 42, so I'm multiplying 7 times 36. 7 times 6 is 42. 7 times 3 is 21, plus 4 gives me 25. Now I'm going to subtract a little bit of borrowing, didn't hurt anybody, and I get 18. So what I do with my remainder, I could put a decimal and keep dropping, but at this point, it's totally cool to say 27 and 18 over 36. Many of you realize that 18 over 36 is just 1/2, so we have 27 and a half. Let's move on a little bit more to a couple other problems. So here I had a few really strange mistakes. 6 times, this would be 10,000. So 6 times 10,000 plus 7 times 1,000 because it's in the 1,000s place. Plus, no need to identify the 0. 5 times 10. And then plus 1 times 1. Similarly here, 2 times 1 plus 9 times 0.1 plus 4 times 0.001. Here, this was really a calculator pushing exercise, and I'm going to just write down the answers that I had there. 371,293, so that's 371,293. And then here, you could have gotten, I don't think anybody did this, which is 1 over 8 to the 6th power. Or if you just plugged it into your calculator, you got something that resembled this, 0.00000381467 and lots of other stuff. So really it was just making sure that you can use a calculator. At this point, we're going to look at these answers. If there are 100 centimeters for each meter, then that means if I have 245 centimeters, that's just 2.45 meters. In a sense, I'm dividing this by 100. If I know for each liter there is 1,000 milliliters, then I'm going to multiply this by 1,000, and I get 3,600 milliliters. Here, I know that again, the kilograms, there are 1,000 grams per kilogram. So I'm going to divide this by 1,000 and I would get 19.2 kilograms. And finally, I still know that there are, for each 1,000 milliliters, there's 1 liter. So I'm going to divide this by 1,000 and I get 0.591. Over here, let's see. So if I have 0.958 or 958 thousandths, I need to look over and see where that would be. And I'm confident that that would rest after the 0.95, but not that far up, not at K or L. I'm really confident that that's at M. It's just a bit away. 9.25 is going to be between the 0.9 and the 0.95, so that's N, and 0.995 should be pretty close to 1.0, and I would get L here. And this is a little deceiving. Use the number line above to help you round. I think I'd rather you just round, and what you should have gotten was 0.91. I'm not sure if the number line was really helpful in thinking about rounding. All right, so this problem, I am just going to do some copying and put the answer down for you. Give me one moment. Okay, so what I have here is the stem and leaf plot that I created when I did this. So a lot of people get this incorrect in terms of choosing 82. I think that was a counting issue. You need to really make sure you put all your information in the equation, in the stem and leaf plot in order to figure out what the median is. So you got partial credit for that if you did 82. The mean, if you averaged it, you got 78.7 something something, which rounded to in the 10th place 0.8. In this section, I gave points, awarded points based on how good your explanation was for either one, and I allowed options for both. For this one, we should have gotten 32.8 just by looking at the actual graph. And again, I allowed both answers, thinking that she was being misleading or not. But I personally thought she was misleading in her graph, looking at the fact that this is only an hour increase over that time. So this is only an hour, so we're not actually talking about hours. So I thought that that was something significant. Guys, I hope this was helpful. I look forward to talking to you soon. Let me know if I can clarify anything else from the test. Thanks. Bye-bye.